Alright guys, we're going to try this video for like the billionth time. Hopefully it'll post. So, the status for last week, the standard was SIN 501, which is all about experimental methods and procedures. You're going to see a lot of this in your interim in about 2 weeks. So, why was the study designed so that the 3 experiments had the initial starting volume of 10 milliliters? These conditions ensured that any change in I2 formation was due to. So, let's read about this experiment. 10 milliliters and 10 milliliters were poured into separate test tubes, 5 degrees Celsius water bath. Water bath remained there until the temperature of both solutions was 5 degrees. Then they were mixed together. The acted as an indicator. The procedure was repeated at 15 and 45 at 10 degree centimeter intervals. Okay, so it looks like the amount of solution is an independent variable. The temperature is an independent variable. And then now they added a catalyst in our other experiments. So temperature and catalysis only, that only covers some of it. Temperature and concentration, only some of it. That only covers 2 things. This one is the one that covers the variables from experiment 1, experiment 2, and experiment 3. So it covers the IV from all experiments. And then if you see something like this, it says ensured that any change was due to. Change in an experiment, you only want it to be because of the independent variable. So that should be a clue to you that you need to look for the independent variable in that scenario. All right, number 2, what was the most likely reason for completing experiment 3? So experiment 3, it was the procedure was repeated, except that this was added. It acts as a catalyst. So we wanted to see how adding a catalyst, right, those key terms match, will change this rate. Catalyst, catalyst. SIN 501 for number 3, in experiment 1 and 2, the variables directly manipulated were. So in experiment 1, they did everything at 5 degrees, poured in a separate test tube, both of the solutions. So experiment 1, it was these. And experiment 2, constant temperature, but various dilutions of solution A. So the first one was temperature, and the second one was concentration. For people that thought these were the same answer, order matters on the ACT. Even if they don't say respectively. So sometimes they won't say respectively, but order, so I'll make a little note here, always matters. So usually you'll see respectively, but sometimes like on higher level ones, so next year when you're not taking interims but you are taking the ACT for real, you won't see the respectively. All right, which of the following was not directly controlled in experiment 3? So not directly controlled, that should make you know that it's a dependent variable, so I'm going to go to here. Dependent variable was reaction time, because dependent variable is always on the y-axis, and that's right there. All right, why were solution A and B mixed at 0.02 in experiment 1? So, to ensure that reaction rate was evenly calibrated, to ensure that reaction rate was due to the addition of H2SO4 only. Nope, that's experiment 3. To ensure that this was due to changes in temperature only. That matches. Concentration, nope, that's experiment 2. So now let's pick between A and C. So what was our variable here? So our variable on this one, we have reaction time and I2 formation, right? Yeah, so in the presence of I2, that's why the answer is C, because this one doesn't match. It says time, which would basically be the same thing, but because it says rate, not time, we're not going to pick it. And then I2 formation is what they talk about in experiment 1. All right, our next little set. Study 2 was likely performed in order to determine what? So I'm going to go to study 2. So So study 2, viscosity measures the resistance to flow. So we wanted to figure out the viscosity of a whole bunch of different metals or samples. So the viscosity of the samples per concentration, right? Because we have actually 3 independent variables. We have the temperature, we have the concentration, and we have the type. So let's see. Determine how the type of volcano. Nope, it doesn't tell us that. Determine how mineral type and temperature affect the viscosity of lava flow. Yeah, we could say that. How mineral temperature and rock type. It doesn't say that. Determine how volcanoes through different basalt systems. It doesn't say that. So that's B. So we use process of elimination for that one by matching the specific key terms. Which of the following was a dependent variable in study 2? So study 2, dependent variables are on the y-axis. So that would be the viscosity. So, yep, we only had one y-axis. All right, scientists most likely studied the mineral content at 6 locations because, so we looked at the mineral content of 6 locations. The types of rocks were these types of rocks. So why would we study these 6 locations? And in science, if we're only studying those 6, it's because we think those 6 are the ones that matter. So 6 is the minimum requirement for a representative sample. No, we don't have a minimum. There are only 6 known minerals. It doesn't say that. Only 6 locations in the world. It doesn't say anything about that. So this one would be the most scientifically accurate, right? So this one is the one that tells us it matters. Why does it matter? All right, number 9. Which of the following was not an independent variable studied and tested in study 2? So let's see. Temperature was an independent variable. Parts per 100, so that's concentration. And then type of mineral. So we had type, temp, and concentration. Temp, parts per 100, mineral type, those are all on the independent variable sides of the graph, so flow rate was not one. And the last question, in study 2, which of the following was done to establish a baseline before variables were introduced? So let's see, what did we do? Scientists heated finely ground rock samples and calculated the viscosity by observing the flow rate of molten samples down a sloped surface. Scientists measures the viscosity containing 100 parts for these locations. Process was repeated. So it's the first thing that they did was was not pulverizing them. They already had done that. Cooling the samples. Nope, 1200 degrees isn't on there. But they did put them down a slope. And then no. So this one matches key terms. Description. I can't spell today, guys. Whoops. But it matches the description. Happy annotating.